First things first, one cannot really talk about event sourcing without at least touching on subject like DDD, like CQRS, maybe EDA also. But I will try my best to focus only on event sourcing. If you want to talk about these other topics later, just catch me. So, in our applications, we often deal with some objects, be it shopping baskets or invoices, documents, like users, anything like this. We often store them somehow, more or less persistently, for example, in the form of a database table. And we are so used to store their current state. Now, imagine that if beside the current state, or even without, instead of the current state, we would store their history. Each individual transition led to the object's state. And with this data, if you are able to recreate current state on demand, and if you are at this moment still able to act on these objects, for example, make some modifications that led to another transitions, then we have event sourcing. That's basically it. Now, in event sourcing, we no longer just call these objects, we call them aggregates. You might think of these as aggregations of events. Aggregates can do a few things. Aggregates know how to replay their current state from events, from these transitions. They use event handlers for that. This may be just class methods. They also know how to execute commands on themselves. They know how to handle our actions on these objects. Aggregates can be relatively simple. For example, any user may have some values, some attributes attached on them. For example, I don't know, some strings, some numbers, and these simple objects we call value objects. Aggregates can be more complicated. And then we have a top object that is now called aggregate root. And they may have sub-objects within themselves. We will call them entities. For example, imagine that we are modeling an invoice, where an invoice is an aggregate, but also it has positions that can evolve over time, because we can modify these positions and not just replace them like value objects. So this looks very fancy, but why would we do it? Most often than not, when we are explaining event sourcing, we are using a trivial example of an account balance, where you add some money and subtract some money from an account. And this is a very simple example. There are only one or two event types, very trivial event handlers. But we are not here to talk about trivial examples. And here enters Growbots, the company where I am a software developer. And what we do, we call sales automation. We maintain and expose a database of business contacts within companies, basically contacts to people. We allow our clients to define a selling target on the contacts. Then we automate what we call outreach, initial contact to these clients, mostly email. So our clients can define these emails that will be automatically sent. Yes, it's some kind of spam. Keep in mind, this is a business-to-business communication, not to like regular people. Sorry. We also track whether these people, which are now called, at this point we call them prospects. This is a sales lingo for potential buyers. We track whether they replied, because we don't want to continue to spam them when they are interested or not interested. We also have CRM integration for all of them. And in these two areas, we use event sourcing. What may seem relevant for all this topic, but it doesn't need to be, is that we are a software as a service, so we maintain a web application. We use web services, but you can also apply event sourcing to a monolithic application or maybe not related to web at all. For real live storage, we mostly use RDBMSs, mostly Postgres instances. It also doesn't need to be that relevant. What problems do we try to solve with event sourcing? First, this is more related to this outreach area. Our object, prospects and everything underneath, had a decently complicated business logic. And this business logic is not only complicated because of itself, it's complicated also because it may need to look at any number of previous transitions, previous events that happened to these objects. In our application, we had very many moments that we tried to solve some issue or look at our usage or something like this. Well, depending on, for example, logs coverage, sometimes it was either hard or even impossible to trace something. And on the top of that, well, there's always some history attached to any of our prospects. Users wanted to see this history at some point. So we slapped some ORM model and tried to just write to that model, write these events and expose to our clients. But at some point, we have all these problems. There's a pattern that may help us. And this pattern is event sourcing. So we learned what it is, how to implement it, how to start basically. We got pretty passionate, we read a lot, we watched a lot of talks, we even attended some training sessions for that. We thought a lot about how to best approach our problems, how to best implement all of this. We talked a lot between developers, how to implement stuff, what storage engine to use, but also talked with designers, with product owners, to best understand what our problems and what problems of our users are. Because that was a rewrite of some service, and we wanted to facilitate the occasion to improve some things. So during all of that, we did our best to perfect our ubiquitous language. This is of course a DDD term, but it doesn't matter here. This helps a lot, not only with implementing event sourcing, it also helps a lot during later working with the application. So ubiquitous language, of course, is deeply connected with a domain. So the set of our business logic, our objects, this kind of stuff. And at some point, we stopped just talking and learning. Of course, we started this real work. And this starts with defining what our events are, what our aggregates are. And this is not a very linear process. Of course, we need to start with events. Well, of course, maybe not. How to start? When you are in your domain for some time, you pretty much know what events, what transitions of your objects are relevant to your business. This is a first approximation of these events. You may need more, you probably won't need less, but it depends. You may also think of this in terms of what you are currently logging, because maybe these transitions of some objects may also be relevant to you, to your users, to your application. And with this comes defining your aggregates, because this may look trivial, but it's really not, because aggregate constitutes some thing that is called a consistency boundary. It is a hierarchy of objects. Think, for example, for that invoice example, a hierarchy of objects that are bound to change together. And at first it may look like why. Then you come into concurrency stuff, and this becomes relevant. So as I said, this process is not very linear. You will start with some set of events, then try to define aggregates on them, and then likely come back to events because well, we can't store all of these events. They will be too much. We need to change something here, and this will need some iterating, and it's okay. I will talk a little bit about code. I will show you a little bit of code. Just remember that I'm not trying to impose some particular implementation. It's just to give you some idea how it may look in Python. I will focus on one of our services that has this clean architecture stuff implemented, where the domain is completely separate from the infrastructure outside, the infrastructure, persistence, and so on. But we also have a service with event sourcing that is deeply coupled with infrastructure stuff. Basically, uses anotherand underneath. You can do both. Also, I will refer you to the talk from, I believe, Friday, yes, about the clean architecture. Go see it once you have an occasion. So, how it may look in Python. We have a pretty simple base class for events, and each event knows. Well, we have an initializer that we use for creating new events when we execute some action on some aggregate that results in new events. That class also knows how to serialize an instance, how to be put into, for example, database, and of course the other way around, how to unserialize something from the storage back to an instance. Next, we have classes for aggregates, and pretty similarly, we have a class method that we are using to create new aggregates. They basically results in some aggregate created events. This class also has multiple, one event handler per event type, which knows how to apply event onto the aggregate, and command handlers, methods, that either result in new events or they raise exceptions when something goes wrong and the aggregate decides you cannot execute this command right now. Speaking of clean architecture, our repositories have a little protocol with aggregates that know how to basically persist new events. So each of our repositories has a persist method that takes pending events pending persisting, and inserts them somehow depending on the repository implementation. So on the other side, the aggregate just knows how to return these new pending events. That's pretty basic. How to test this stuff? Tests for event classes are pretty boring because we only basically have two methods. So we test whether serializing returns the correct stuff and the unserialized class method returns a correct instance. The tests for aggregates, for commands, are pretty much like this. Given some state of an aggregate, we execute a command and we see whether pending events are correct. For event handlers, also pretty simple. We have an aggregate in some state, we have an event object that we apply to an aggregate and see how the state changes. At some point, we had a pretty nice idea how to implement this code for the domain, and we needed to think about where we will store these events. And as I said, we went with our favorite RDBMS. We mainly use PostgreSQL instances for our services. You can also use any other kind of RDBMS, MySQL or whatever you want. There are also specialized stores for events. Yes, this is a name for one particular implementation. I will link to that later. But whatever works for you, whatever works for your particular use case, is just enough. You need to evaluate what you need. One of the requirements may be getting all events for an aggregate. That's a pretty usual requirement. Sometimes even that is not needed. So whatever floats your code with. What do we need in the store? Well, an ID of an event, pretty basic auto-incremented integer. We will need an aggregate ID, so we know which events go into what aggregate. We will need a version of an aggregate. That is a number of an event within some aggregate. So this is not an auto-incremented by the database. It's assigned by the application, and I will talk about this a little bit more later. But over these two fields, we need an index, a unique index, so we can the first thing, so we can fetch events for this aggregate, but also for concurrency. I will talk about it later. And we will need some payload field, and having this as an arbitrary bag of things, so a JSON column or just a string column with JSON inside it, will help a lot during later implementation and in changes, especially. We have some more fields in our event store, but they are not really. They may be needed in your cases, maybe not. So event type may be useful for querying the event log. We are a multi-tenant application, so we divide our event store by this tenant ID. We have a correlation ID column that correlates events with another events, but we pretty much don't use it. And we can also have a timestamp column, which could also go into the payload itself. But maybe for some visibility, when you want to see when something happened right in your event store, well, this may be of some help. I was talking a little bit about this index, about concurrency. What the hell? So, not always, but most often than not, you will need to store your events per aggregate in a particular order. You want to know in which order the event happens. There's a case, for example, of a account balance with infinite debt, and then you theoretically don't need an order. You can process all the transactions in any order and it will still work. But this is rather an exception. This also touches on the topic of concurrency, concurrent execution of commands to aggregates. And we, in different services, use different kinds of concurrency control. In one of them, we use pessimistic concurrency. We lock our aggregates beforehand using select for update, for example. And in another service, we use optimistic concurrency using this index. Because if two commands want to add an event to an aggregate at the same time, they will result in the same version number, and the database transaction will fail for one of these executions. So we were at the point where we are pretty happy with our design. The implementation was almost functionally complete. But we needed to search for our aggregates. We needed to query them, and we cannot query the whole event store each time we, for example, want to search for a particular prospect by some property. This is where projections come into play. Projections are also called views or red models. And what are these? They are a result, a materialization of a function over events, over all events, over subset of events, whatever you need. The thing is, they introduce some particular complexity. I mean, they may be sometimes built synchronously to the transaction that inserts events into the event store. For example, if you have a red model that stores one row per aggregate, building it synchronously is kind of possible. But most often than not, it is not possible. You need some kind of worker. You need to, of course, maintain this worker to build the red model for you. And eventual consistency, of course, inevitably happens. The thing here is the...
Yes? Can I ask a quick question?
Sure.
Because you said you couldn't query aggregates. So can you tell what are these aggregates and how are they stored? Are they just database tables with objects or something else? Mm-hmm. If they are database tables, why couldn't you just query about the current state of an aggregate?
Okay, so the question was, if we are storing aggregates, why can't we query them like directly? The thing is, we don't store them per se. Our main source of data, our source of truth, is the event store, so a table of events.
Oh,
and
so
aggregates is something abstract at this point.
Okay, yeah.
Mm-hmm. So we of course can make an aggregates red model, and it still is a red model. Okay. The thing here is if you want to go into asynchronous building of the red model, the sooner you will get used to eventual consistency. There's no way around it. At least I haven't seen it. So, at the very long last, we put our app into the production. We were decently happy with how it works. And then, also, inevitably, we needed to make some changes to our app, to some events even. And this is, let's call it evolution of events. Where we needed, for example, to add some fields to our payloads, or change a meaning of one of event types, or add an event type. This is where having this payload stuff as an arbitrary JSON helps a lot. You really don't want to store your payload as separate columns with some sparse table events. Having this payload serialized is much better, at least for us. Sometimes our event types changed meaning a little bit, and if it changed sufficiently, so we wanted to have a separate event handler for that event type. We wanted to version them. Don't confuse that version with the version of an aggregate. And we were just slapping v2, v3, and so on onto the event types.
I have another quick question, because you mentioned there was a method applied event on an aggregate. So if you don't store a state, what does this method actually do? For example, you have an event that says an account balance incremented by $2. What does apply event do if it doesn't store any state on aggregate?
So So what does the apply?
How the event is applied to the aggregate.
What does the apply event method do? Without any optimizations, you fetch all your events for an aggregate and reply the current state using event handlers. So it's not that you have some state and then apply a single event.
Okay.
You get all of the events and apply them sequentially.
Beginning of the world?
Yes.
Okay.
Without any optimizations, snapshotting, and so on.
Okay, I see.
And another hard truth, at least for us here, is that changing events, introducing new events, this is a huge depth factor. And the depth you can sometimes, depending on your requirements, depending on your events retention policy, sometimes you cannot really pay it back because you need to still maintain these apply event handlers. These event handlers, you need to maintain them as long as you need them. And there's really no special way around it. Our app was working in production for some time, and sometimes we as developers, sometimes our customer support team needed to see what things are in our data, what state are in some of our aggregates. They needed to query it, and with storing the current state, it's pretty easy. You can just go into the table and see that this user has this state of some field. And with event log, it's not that easy. Another hard truth here is you either implement something for it, either implement some new storage, some new read model that will help some particular use case, or you implement some tools that will help you. So another new work for us. Yeah. Keep in mind, it is also more powerful because you can, for example, see a state for a particular object at some point in time, because you have events, because you have transitions. And speaking of event log and looking at it, events are immutable, right? Like when you put something into an event store, it's there as a fact. By the way, I'm talking about event stores that are like private to our services. These are not shared among services. This is a private storage for a service. So yes, the event stores are immutable in a regular operation. But sometimes, at least, well, there were situations connected to our errors on our developing side. We made some mistakes that resulted in faulty events. Events that, for example, have a wrong field, some wrong value in the field. And we were faced with a few options. One of these would be to implement new code that would handle something that is called corrective events, I believe. And we would add these events to the event log to correct our state. And another option would be to break the rules and forget about immutability for a second and just modify the event log. And we went with the second option each time because it was much more economical for us to do. Of course, depending on your architecture, on whether you are exposing this event log forward, this may be not an option, it may be a hard option. You still need to consider it. I was talking about a service that we rewritten using event sourcing, but we also introduced event sourcing to an existing application. This CRM part. This was where the ORM is used underneath the domain. Isn't really that much separated. So what I mean here is that it's not very easy having layered architecture of any kind, hexagonal or onion or whatever, helps a lot, but it's not really required. Well, this is definitely possible. This is what I mean. Just to give you an idea of what numbers are we dealing with, what amounts of data is that the bigger of our event stores is right now at about 300 million events. Not a lot, I don't know, no idea. They take up this amount of gigabytes, 640 in a Postgres, one single Postgres database. We are starting to think about logical split of this by this tenant idea I was talking about, but we are not there yet. And when we are fetching an aggregate for example, to execute a particular command on it, it takes an average 50 to 100 milliseconds for 95% of cases. And we are storing at most 200 new events per second in like high time. So these are not very high numbers, nor very low. I don't know how to weigh them. I told you that we didn't at any point we didn't use any compensating events. We also don't do snapshotting. In our case, the aggregates are very short. I mean, the median amount of events per aggregate is, I believe, 17. So snapshotting doesn't make any sense for us. But if we would have long aggregates, I mean a lot of events per aggregate, then another thing comes up, the snapshotting thing, where you, when you, for example, periodically store an event that has current state. So you would need only to fetch a subset of events for an aggregate, not all of them. We also don't use any event sourcing library or framework. One, because well, there are frameworks for that, also in Python. One is called just simply event sourcing. I will link to that later. At the point where we were starting with event sourcing, I think I didn't come across it for some reason. I can't really remember. Also, we went a little bit with not invented here syndrome, if anyone knows it. We wanted to implement it from scratch to learn as much as we could. And we decided that using an existing library or framework won't give us as much. Would we make this same choice again? Probably yes. I can't really, I'm not sure. I wouldn't tell for sure that we use an existing one. Maybe it would structure our code some different way, some better way. I can tell. I was talking about two particular services among our app, and we have a lot more that don't use event sourcing, and for good reasons. The places where we have event sourcing is where our business logic is most well suited for working with events. It's decently complicated, has decently complicated interactions between objects, and also the exposition part, the place where we want to share this event log, well, not directly maybe, but the history of our objects to our clients is visible the most. But if your domain or any subdomain in your app is not that complicated, well, you need to answer it for yourself whether event sourcing will help you, whether it will be worth all this complexity I was talking about. So what is also involved when going to event sourcing are all this stuff. DDD, the aggregate, the events, the topic is strictly coming from DDD. Repository pattern will almost always come into play when you are implementing event sourcing. Layered architecture helps a lot. Secure REST, well, I mean, having red models is also almost always a necessity. And sometimes you want to structure your whole application, your services, so that they communicate via events. This is called EDA. And it's also somehow connected with event sourcing. So, wrapping things up, there are, of course, disadvantages of event sourcing. And the biggest one is here. And I cannot stress this enough, you need to make a lot of upfront cost before you are like efficient with this kind of architecture. You will need to deal with eventual consistency, almost for sure. These events handlers for events that you no longer produce, but still need to have in your event log and handle in your aggregates, they become unremovable. And also, yeah, the architecture overhead overall is decently big for us. But there are advantages. So now we are storing history, transitions of our objects as a first-class citizen. We either don't have enough events, and then our application doesn't work, so we fail fast, or we have enough data to be sure that we are really storing the history. This is somehow in contrast to logs, because you might forget to log something, you might change the login level at some point, this kind of thing. Somehow, when structuring our business logic around events, the complexity in the business logic didn't disappear, but it was structured better. It's not magic, this complexity here doesn't disappear, but yeah, it improved things for us. It forced us a bit to think more about how things change over time. When we have visibility in how our objects change, what the transitions are there, it got us a lot better about thinking in terms of time. Also, we got better about thinking about interactions between these, not only objects, but transitions within objects. And in the end, we got a lot better during this whole process about thinking about our domain, our users. We also got better in talking between ourselves about this stuff. So, is event sourcing worth it? That's a question for you. But I hope I gave you enough background to maybe evaluate this idea. Everything that I said, I will link is under this one address, and I think that's all. Thank you.
Okay, and now let's move to the questions. Can one event be applied to different aggregates? If so, how do you handle linking event and aggregate in the database?
I think in theory you can design a system like that. I had no experience in such an implementation, so I can't really help here. Like the idea of an aggregate is that it consists of its own event, and its own tells you that well, no, you shouldn't. But I didn't really explore this subject.
Okay, next question. Speaking of clean architecture, do entities map one-to-one onto events, aggregates, etc.?
You will almost certainly want to map some of your entities into aggregates and sub-entities of these entities to, well, entities here. So this not mapping of entities, but mapping of the nomenclature may be weird, at least at first. This is where you need to learn a little bit something about DDD. So also, if you are thinking about in terms of like an event that is a database model, for example, because you can have a database model for an event. So yes, this will map onto the domain event. For sure.
What is the impact on query execution times to DB when there are joins between multiple aggregates?
The first thing is we really don't want to join anything with the event log. This is pretty much always something you wouldn't want to do. The event log is a base for your other almost certainly red models, maybe other storages if you need, but the event log alone, you don't want to join anything directly. So it depends on the requirements. What would you want to do with this info?
Okay, next question. Why did you choose a relational database for storing the events and not a NoSQL documented database?
From the beginning, we wanted to attach to our storage engine workers that would be somehow notified about new events, so they can act on these events and do some new actions. That's one thing, and we were immediately sure that Postgres will handle that. Another reason might be that when it comes to NoSQL, we only use Elasticsearch for search and nothing else. Maybe that's another part here. So basically, we didn't see any value in using a NoSQL storage.
Okay, next question. How do you deal with storing tons of events in the database? Supposing you have lots of events per hour, do you have some retention policy for them?
For now, not. We still have all of our events in this event store. And as I said, we are starting to think about logical partitioning. Starting. We are not here there yet. The database handles all of this data just fine.
But in theory, if you would do the retention, would you like squash the events, or how would you do that?
If we wanted to introduce some retention policy, would we squash the events or would we remove them? That's a very business-oriented question. For us, it possibly would make sense to delete some data at the tail. For us.
But isn't it like that you have to have all the events in order to reproduce the final state? Because you have like the base state, then you have the events, right? And out of those events you build the final state, right?
Yeah, that's...
So if you don't have the base events, you wouldn't have the complete thing, or how does it?
So if you would be removing any data at the tail, of this event store, we would need to only remove entire aggregates that are no longer valid for us. And again, this is a very, very business-oriented question. It depends on what data do you store, what aggregates do you have.
Next question, which libraries could you recommend?
For event sourcing, I believe. Okay, I can't really recommend any because I haven't used any in production. I will definitely encourage you to look into this event sourcing library. It's called Just That. It is linked. On this page, but you need to evaluate this for yourself.
Okay, next question. As we are talking about the complex solution, you must have been answering lots of design doubts. How to build a foundation, how to manage the project, book record.
I would recommend. There's quite a lot of books written on event sourcing topic. There are quite a lot of talks, and I have both of them linked on that page. That's one thing. They are anchored in mostly a Java world. So the thing here is, forget that it's not about the language at all. It's about the architecture, and you can get a pattern from one language and try to implement it in another. So this is an architectural pattern where you can do just that. But we are starting to have some material about event sourcing in Python specifically. Google it, basically. And for some particular tools, we didn't need any. Like we are located in a single office, so we can always talk and draw on the boards. No, we didn't need a specialized tool for that.
Next question. Do you use the partitioning of event table in Postgres?
No, not yet.
Okay, next one. From business point of view, what did ES actually solve, enhance in your case?
I don't want to really repeat what I said on this slide. This all, however, non-technically, this may look. This is what made us faster when thinking about implementation, when structuring the implementation. So it's not that event sourcing is a magical technical solution that will only be viewed as a technical topic. These have a huge influence over how we think, how we talk, how we structure our tasks and so on. So I believe it got us better in terms of on delivering new features, fixing bugs.
Okay, and next question. Have you tried columns-oriented databases for events? ClickHouse, for example.
Basically not.
Okay, next one. Have you considered using Kafka storage for events?
I believe at the point when we were choosing storage, we didn't have capacity for introducing a reliable Kafka cluster. Maybe at this point we would go more boldly about it. But if I'm not mistaken, it wouldn't be as easy to fetch aggregates from Kafka without having a topic per aggregate. And I'm not sure if Kafka is really built for that. But again, I don't have much production experience with Kafka, so maybe I'm mistaken.
Okay, next one. How do you create read models for related entities? Basically, how does you synchronize their event logs?
So the event log is a singular thing. You don't synchronize multiple event logs because you have one. But how do we synchronize events from various aggregates? Well, if we are building a red model that combines information from multiple sources, multiple aggregates, we fetch their current state at this point in time, or whatever the read model needs, because it has events. It may want to start to use the current state of these both aggregates, or maybe some previous state. It has all the freedom it has with events. So I don't think there's much synchronization here, but we can elaborate later. Maybe not under the example.
Okay, these are all of the questions. So thank you for a good talk and give him an applause.